Now we are going to discuss another concept called generators. So this topic will have 5 relative questions. Generators can help you to pause and resume the code. That is the simple definition of generator functions. Let's get clear with generators in the most simplified way. Normally when you write a function, it returns a single value. You can think of generators as a kind of function which can return multiple values in phases. Enough of definition, let's try practically. The function star is the keyword used to define a generator function. Yield is an operator which pauses the generator. Yield also helps to receive input and send output. But that is the next phase. At the moment, let's use function asterisk, keyword and yield operator to get the idea of basic functionality of generator function. So let's define a generator function. I'll say const, for example, gen function, that is generator function. I'll say function. This is absolutely fine. Now the difference is you put a star here. Sometimes you will see that people get confused with putting this star. Some people write like this or like this. All the ways are correct, but most of the commonly used way with generator functions is that we use the star along with the function and then we put a space. But even if you do not have a space, right, then also it's fine. And if you have this star with this bracket, that's also not a problem. I'm just writing a statement here saying console log. Let's say I want to display hello. Then I just write yield. The moment you write this yield operator, it means this is where the function will pause. I'll explain you with some illustration, but let's proceed further. Another statement I want is hello, then the world statement. Again, I just want to have the yield operator. And next, I'll put a console log. I'll add one more statement and let's say galaxy. Now, how am I going to call the function? I will create an object, let's say generator object is equal to, I'm calling the generator function. Now, if you see this line number 8, when a generator function is called, it does not call the function. Instead, it returns a generator object. So the g_obj here you see will receive the generator object. Let's try to display the value of it. I'll say console log, the generator object value I want to see. I'll run the code. I'll say node generator.js. So you can imagine that you are still here. Now there is another method called next method which will start the execution and will continue till the yield operator. When it reaches to the yield operator, that's where it is going to stop. Let's try to put a next statement now. I'll remove this console log as it is not needed. I'll say g_obj.next. Let's run this. So it has executed the first statement and then when it found the yield operator, it stopped the execution. The next method actually returns an object which has two keys which we have already seen with the iterator. The first is value and the other is boolean which shows the next status. Let's try to print value of next method. Either I take the value in some variable, I can say some object, const o is equal to, we want to check what the next returns. So I'll say console log the value of o. Let's run the code. So hello is executed and then when it found the yield operator, it stopped and it returned the object like this, value and the status done. As you see that the value is undefined. The reason is at the moment I have not returned any value with yield, which you can by giving a value along with the yield. Say for example, I just want to try yield value. It might be any value which you are returning. So yield itself is capable of returning any value. Let's try this. I'll save, run it. Now as you can see here, the value says that it is yield value which was undefined earlier and the status is still false. Now if you want to execute this entire function, because there are two yield operators written here, so we'll have to write multiple next methods. Let's do that. Again I'll say gobj.next. I want to move to the next yield. Even what we can do here is we can directly console log and also move to the next yield. So we do not need to write more lines here now. So this will also move to the next yield and will also display the returned value of the next method call. Let me write 3 times here or even 4 times. Now let's run the code. The first hello is executed here. Then comes the returned value by this next method. Again we write the next, so it's going to move further. When it goes on third next, it is going to execute this AND galaxy. And for the last next, I've just added for the sake of adding it, just to show that there is no value getting returned for the last next. Let me remove this now. Again we try the same code. So this is the output. Inside this generator function, we are moving step by step with the next method. Now this next method we have already seen in the iterator section. It means generators are iterable as well. So instead of writing this next, what we can do, which is a more preferred way, we are going to put an iterator here. When I say iterator, I'm going to put a for of loop. I'll say for, let's say let O of gobj, which is the generator object. Now here I'll simply try to display the value of O. Let's run the code. Now you see that instead of writing the next methods multiple times, you put the loop, that is for of loop, and you can iterate through the entire generator function. Isn't it fantastic? And because here you see that generator functions are iterables, you can use the spread operator with it as well. So instead of writing like this, say for example, even I do not want the for loop and you want the results inside an array, what you can do is you can directly display the value of this generator object, which will not be a generator object later on when I put this inside the array. So whatever the generator function is going to return, because it is iterable, you can use the spread operator with it. So this will actually create an array with returned values. All returned values by this generator function will be assigned to this gobj. So now this is a kind of array. So let's try this also. I'll clear the screen first and run the code again. So now you see that this entire gobj contains the values which the generator function was returning. In the iterator section, we tried a code sample to iterate through an object literal. Generator works best with iterators. This was the code we tried with iterator, where we created a method with symbol iterator key and we returned the iterator object to iterate through a non-iterable data structure. The same code we can convert with generators, and that will be even easier. So like this obj, we have start and end. Of course this system iterator is needed, but we are going to convert this into a generator function, and that's it. This actually converts this entire system iterator method as iterable because now it is a generator function. So what I can do, I do not need all this ITR and anything like this. Even I do not need to return this object as well. Instead of this, you can simply put a for loop here, and let's say let counter is equal to this dot start number. The counter should go till end and the counter will be incremented by 1. The next thing you need is that you are going to yield the counter. That's it. So now you can compare the code which we wrote like this for iterator, and now we have this code where it is going to iterate through this non-iterable data structure. Let's try this and see what is the output. The for loop will remain as it is. So now you can see that this thing is iterable just with the help of generator functions. In fact, to make this syntax easier, you can certainly remove this function keyword, and this star you can put before the symbol iterator, and you can follow the ES6 syntax. That's also fine. This is even better. Let me save and rerun just to check whether everything is working fine or not. And here also, instead of writing the for loop, you can use, let's say you have the obj. This is the object which we have made iterable. Now see the most amazing thing here. I'll directly say console log dot spread operator I'm using obj. That's it. So this is an array where you have the entire list of values. So now we know that generators are really working well with iterators because generators are iterable as well. The yield operator which we are using is something we can use only in generator functions. When it comes to recursive function or even calling one generator function from another, there is a specific syntax, that is by using yield and asterisk like this. Let's try a code sample. I will create a generator function. I'll say function star generator. Right now I'm putting just a statement here saying that hi. Now I'm creating another generator. Let's say function star generator 1. Ideally, when you have to call this generator, that is this one, you will use const, let's say the generator object is equal to, the function name is generator. Then you will say g dot next. So you are actually calling the generator function, because we know that if it is a generator function, we need to move the function pointer using the next method. Now if you call this generator 1, that is I'll say g1 is equal to generator 1 and g1 dot next. Now if you look at the architecture of this code, we have two generator functions here, and the generator 1 is actually calling the generator function here. Let's run the code first. I'll say node generator.js. So here this line is executed. In case if you want to call this function directly, then you have another syntax as well. That is, you can use the yield function and you put an asterisk here. Then you say gen. This will help you to call the generator function. As you can see that the function is executed. If you had to write the yield outside any generator function, it is not allowed, because yield is something which you have to put inside a generator function. But here this situation can be very well handled with yield asterisk, and then you give the generator function. In case if you have a recursive function, now let me just show you one simple syntax of recursive function. Let's say I have a function called factorial. Now what is a recursive function? A recursive function is that you may have some if condition here, and then you may want to write some exit statement, that is to terminate the execution, and here you will call the factorial function. So right now what we are doing is that we are calling the factorial function from the function itself. It's a kind of endless execution unless you put the if in a proper way. So this is a recursion. Now in this case also, if you want to call, let's say this is a generator function, assume that this is a generator function, then you can use the yield and star. Of course, in that case also you need to have proper conditions to come out of the execution. So in case if you want to call the generator function from another one, or you are implementing recursion with generator functions, then you can use the yield and asterisk syntax. The generator object has next method, which we have already seen, which returns object like this. It also has two other methods, return method and throw method. Return method is more or less similar to the next method, but it returns the object like this, where you have the value and done will always be true, and it terminates the generator. So return method is used to terminate the generator here. Let's try this. I'll create one generator function. Sorry, I missed the generator, that is the asterisk. Now let's say yield. I'll return straight away 1 and another yield. I'll say 2. Now I'll create the generator object. Let's try this. Console log generator object dot next. At the moment I'll try with next method only. So I'll write the next method 3 times. Let me do that. And we are straight away displaying the returned value by the next method. Let's run this. Now you see that for the first 2 next methods, because we have already seen the execution, that once you write this statement, the pointer is here. When you say the next method, it moves to the next value. So this is executed because yield is something which pauses the execution. Then the second next will move to the next line. The last next is going to say that now done is true and there is no value returned because there is no yield for this next. Now you see that the done true is displayed at the last next method call. Let me just say return here. I'll save this and run it again. Now if you compare the output here, in the second call itself, it says that the value is undefined and done is true. It means that on the second call, because we have used the return method, it has terminated the generator, right? And it has made this done is equal to true. So now there is no more further execution possible. The same thing if I write here on the first line, let's say return here, and I'll put next here. Doesn't matter whether I write next or not, but let's write it. Now as you can see, all 3 times there is no value returned by yield because the generator function is terminated on the first call itself. So if you have a situation where you have a condition and then you want to come out of the generator function, you want to terminate the generator function, you can write the return. In fact, you can give a message also. Next method also takes a parameter if you want. Same way you can say that, let's say there was a condition satisfied and you wanted to come out of the generator. I'll just say condition done or satisfied, whatever. I'll just save this. So now you see the value is condition done and done is true. So this is how return is useful to deal with termination of generator function. Now in this example, we have already seen that we can terminate the generator function using return. You can also suspend the termination if you are using finally and you use the yield statement in it. Let me show you practically, then you will have a clear understanding. Let's say I have a try block here and the yield statements are placed inside this try. Here I'm going to use finally. Now I just use yield and I will return finally here, just to get the idea that this is actually returned by the finally yield. Now here I have this gobj. I'll say gobj.next. Let me also put a console log here so that I get the output. So the first is the next statement. The second line I'm going to write is again the next statement. Let's run this and see what is the output. So both the cases it says done is equal to false. Let me comment this yield at the moment and here I'm going to write return. Let's try it again. So now what happens? First case done is equal to false. The second case it says done is true. The reason is we have used the return statement which terminates the generator. Now if I just uncomment this line and if I run, you see the second one is not yet terminated. The value is finally. This shows that the yield statement of finally is executed and done is still not true. That means the suspension is executed. When I wrote this yield in finally, the return method's termination is suspended. So this is another syntax which you can use sometimes when the termination is to be suspended. The next method we are discussing is the throw method. The throw method throws an exception at the location of yield which made the last suspension in the generator function. It means that, for example, in this case, instead of writing finally, I'll just put a catch here and let's say error object, and instead of having a yield statement, now I'll say console log and display the error, whatever the error is. So I'm going to join the error err. That's it. Now instead of this return statement, I'll use just a throw statement, throw method that is, which will throw the error. And as you see that the first next did return this object, but then because we have the throw, right? Now see here, return or throw which I have shown, this is just an example or a syntax or how does it work. That's what I am discussing, right? You have to correlate it with some practical situation. We are also going to see few situations where we'll be using it. But at the same time, you have to understand that when I use the throw statement, that means if there is an error condition, I'm going to write throw or maybe return. But all these methods will be in a kind of if condition, or in some situation only we are going to use it, right? So there will always be an if condition, maybe switch case, where you see that if certain values are or conditions are not satisfied or maybe satisfied, then you want to terminate or generate the error. As long as error is concerned, anyway, whenever there is an error generated by a try catch which you generally use to handle the JavaScript errors, that's where you can have the generator function object dot throw method. In this section we have just seen the syntax of generators and how generators are working with iterators also. As long as the practical implementation is concerned, I would like to underline this, that generator functions are rarely used in your JavaScript code. But yes, there are situations where you have the asynchronous processes where iterators and generators combined, they can work well. And to see how generators and iterators with asynchronous processes work, you can check the asynchronous section where I have discussed asynchronous iterators and generators concept. Let's discuss relative questions of this topic. The first question is, what are generator functions? Explain the syntax. So generator functions, we have seen that they give you a way where you can pause a process, and then whenever you want to continue further after some time even, then it's possible. The syntax is like this, where we are using an asterisk with the function and we use the yield operator to pause the execution and next method to proceed further. The second question is, which is the right syntax? Function asterisk then space, or function then space and asterisk? See, we have already seen earlier in the beginning that whether you write space after the star, before the star, or even if you don't give a space in between, that is the function parentheses star and brackets, you do not give any space, doesn't matter, right? All these syntaxes are valid. But at the same time, I would just like to emphasize that function star space is the commonly used syntax. So we go with this way of writing the generator function. The third question is, explain all methods of generator object. So the three methods which we have discussed, the next method, which actually moves the function pointer to the next line, from the next, that is the last suspended yield, it proceeds further, whereas the return allows you to terminate the function, and the throw method, which can help you to raise an error with the generator object. So these are the three methods related to the generator object. The fourth question is, explain the use of yield star, that is yield asterisk. So we have seen that it's about calling generator function from another generator function, or even when you have to call a recursive generator function, then you have to use the yield star syntax. The fifth question is, can you prevent return from terminating the generator? Yes, absolutely. Of course, there should also be a conditional way to deal with this situation. But when you say return, it terminates the execution. But let's say if you write a yield statement in finally like this, then it will certainly prevent the return from terminating the generator.